All right, let's do another example. So let's look at the same data set, but now let's basically ask ourselves, does this sample come from a population with the true mean whose weight is greater than 1.99? Assume a confidence level of 99%. Well, we are going to, again, first step, define our null hypothesis. We're always going to set our population to whatever the value is here. So we're going to set this as such. Alternative, now we're asked about greater. So this means, obviously, we are beginning to doing a right tail test. What's our confidence level? Is equal to 99%, or our alpha equals 0.01. And since this is a right tail test, we're not going to be divided by 2 because we're not symmetric. So we're only looking at one side. So it's a right tail test. All right, let's go ahead and let's calculate our values here. So let's kind of do something very similar. So let's set this up over here. We want to look at what we did. Let's build this out a bit. So actually, let's full screen it. We're okay. We can remember. So we're going to do our values here. So we're going to say that t experimental, we need the mean because that's our x bar. Our mu is now this time 1.99. Standard deviation is staying like the same, so we can control enter. 2.025, excellent. Alternatively, we can go ahead and do our t-test. Our confidence level now is 0.99. Our alternative is not two-sided. Instead, it is going to be greater, and our mu naught is 1.99. So we can go ahead and shift enter that right now, and we get the same t-value, which is good. And now we have this p-value. Let's come back to that in just a bit. Let's see if our confirmation is the same. So this would be our t experimental value. Now, t alpha nu, that's going to be t 0.01, and our nu is still 17. So let's look at that value on our chart. So now 0.01, 17, 2.567. Let's go back. Let's see if that is correct. 2.567, excellent. Let's look at our right tail test. So on our right tail test, 2.567, we see over here, where is our experimental value? 2.025. So we should be in the reject region. Does that match with our value here? What's our confidence interval? 0.01. So this is greater, so we know that effectively, again, this matches. If we're greater, remember, we have to be on that other side. We have to be in this do not reject regime. We're close, but we're not there. So there it is. Good double check. So it's great you can do this both ways, and you'll definitely get the answer. Let's look at, so we did that, fantastic. Good, good, good. Let's do another one. So now let's say less than 2.01, confidence level of 90%. So we can still have this. I think we're getting it now. Now our alpha is equal to 0.1. It is a single-sided test. Let's go ahead and calculate an R. So we're just going to copy this right here. So I think we're still 1.99 if I'm correct. No, 2.01. So we're doing less than. So 2.01. So we can see that's our t value. Our confidence is 90%. We are less. And then our mu is 2.01. So we still got the same t value. P value is 0.48. That's not going to work. So it looks like we're in the do not reject, but let's double check. So my t value is going to be the same this time. However, still the same value, but you see the negative? Why is that? Because we're on a left side. So it has to be negative that value. So it's negative. Our value of minus 0.4, what is it? Minus 0.04, whatever it was. Let me just double check here. Minus 0.04, that's not going to cut it. So we are definitely in the do not reject regime. What happens if you have a larger sample size? Well, instead of using z, you can just use, I would use the same equation for t, but when it gets to t alpha nu, set nu equal to infinity, and you'll always have the same value. So you can look on this table, for example, and you'll see just this value of infinity. You can see it's not going to be exact, like the value changes slightly, but it's good enough. It's good enough for me. I'll be sufficiently happy with such an answer. So let's do a large sample size. So let's go back to let's look at the rolling of our beads comes from a population velocity of 3.1 at 99%. So this is less than, excuse me. So that's going to be left tail test. So let's go ahead and let's try to pull in our data. Where's our files? So let's go ahead and do rolling v. I'm going to say rvdat. Read underscore xlsx rolling velocity dot xlsx, and then we can just copy and paste here. I think it was 3.1. Actually, we can copy and paste here too. Oops. Again, you're encouraged to use R on your problem set. Never ask. You can always have this on the exam too. So I believe it's 3.1. Let's double check 3.1. And then let's just replace PCMDAT with RVDAT, 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 RVDAT. All right. So minus 1.48. Again, the data is a little bit different because I read it in differently, but it's okay. So that's our value here. Let's see if we get the same. Actually, let's double check that. Yep, 3.1. I'm going to Control Enter here. And we see we get consistent values between these two, which is the most important. So we get a p-value of 0.06. So remember, our confidence level is actually what? So our confidence level is actually 0.01. So if we divide that by 2, it's actually 0.005. So actually, there's an error here that we need to work with or change in our notes. So excuse me, no, that is not. I keep thinking for some reason today it's a two-sided test, but no, it's t of 0.01 and it's infinity. So we can again look at that. Since it's left-sided, it has to be negative. So that would be negative 0.01, 2.326. Let's go back. Sorry for switching back and forth, but we need to do so. All right. And we see again, we are in the do not reject regime. Darn it, we can never be in, we want to reject things. All right, so next time we're going to get into t-test comparisons and looking at the p-values there as well. So we'll see you all next time. Thanks. Bye.